All right, so here we have new car revenue. So the function Rx, billions of dollars, models revenue from new car sales for franchise new car dealerships in the US when X million dollars are spent on associated advertising expenditures from X between 1.2 and 6.5 million dollars. So we have R of 1.5 equals 1.41, R prime of 1.5 equals 38, and we're supposed to write a linearization model with respect to x at c equals 1.5. So we've been doing that. So we're going to have some RL of x is equal to R, which is 141, plus R prime, which is 38, times x plus, or x minus, sorry, x minus 1.5. Okay, so that will be our linearization model based on the information they gave us here. Now B says, well, now find RL of 1.6. Notice we're using 1.6 because it's in $1 million, and we know that X is in millions of dollars, and so we just want to plug in 1.6 for the X, so we have 141 plus 38 times 1.6 minus 1.5, and if we plug that into our calculator, it looks like we get 141 plus 144.8, and that's going to be what? It's going to be billion dollars. Okay. And so, well, I guess one thing we should do here, because we were used to writing all these models without any information, but this one actually does give us something. This is going to end up being $1 billion, okay, of revenue from new car sales, and when X million dollars is spent on advertising. We'll shorten it a little bit. Okay, and we know that 1.2 less than or equal to x less than or equal to 6.5. Okay, all right, so that gave us the first one. We got 144.8 billion dollars. Now C says now do RL of 2. Well, that's 141 minus or plus 38 times 1. Well, I can't write anything. I'm trying to read here and not go 2.0 minus 1.5. Now we do 141 plus 38 times, and it's going to be a 0.5, so that's going to be $160 billion. And so that is going to be our estimated revenue when there were $2 million spent on advertising. Okay, let's do another one. All right, so the estimated releases of CFC 11 between 1990 and 2009 are modeled as GX 1,000 metric tons, where X is the number of years since 1990. See our graph. So this is kind of our model we're going to use. Now it says use 2008 values. So we have that to write a linearization model that can be used to estimate other values for CFC 11 releases, and then use that model to estimate in 2009. Okay, well, let's call it GL of X is equal to, well, it's 38.3. And then it's minus, so let's go ahead and just put our minus in, 4.9 times X minus, and we're using 18 in this case. And again, if we're going to write everything out, we would say, okay, well, that's going to be equal to 1,000 metric tons of CFC production since 1990. Okay, so that's kind of, we'll shorten it as much as possible, and so that will be, oh, that's releases, not production. Well, I guess it's production into the atmosphere is what I meant, but we'll go ahead and say releases. All right. So now they want GL of and 2009. So that's going to be 1990 to 2000 is 10 plus 9 more. So that's going to be of 19. And that's equal to 38.3 minus 4.9 times 19 minus 18. And so that will give us 38.3 minus 4.9 times 1, 33.4 thousand metric tons. Okay, of CFC. Then B says we're going to create a new model. And now we have just different values. And these are the 2007 data. And so this is GL of X equals 42.2 minus 2.9 times X minus 17. And so that's going to be, again, 1,000 metric tons of CFC released since 1990. And now they want GL of 19 again, except now we're plugging it into this. So that's going to be 42.2 minus 2.9 times 19 minus 17. And that's going to be equal to 42.2 minus 2.9 times 2 and 36.4 thousand metric tons. Okay. Now it says for C, the actual amount that was released in 2009 was 37.7 thousand metric tons. Which estimate is closer? Well, which one's the closest? Well, this one is. So for C, it looks like part B was closest at 36.4 thousand metric tons. Okay. And that's all it asks. So that would be our value. All right, so let's stop there and we'll come back for more.